All right, it looks like we're going to get started here in just a minute or so. We still have folks joining the webinar, but this is Joseph Jacks speaking, and would like to thank everyone for joining our webinar today. So we'll just give it another minute. We'll get this started. Okay, we're going to get the webinar started. So thanks everyone for joining the webinar today. Good morning, good afternoon, good evening, wherever you are in the world. We've had really great reception from folks all around the world joining this webinar. And I'm really excited to be co-hosting this with my friend Jenny Karam MSV from India, and so I'll just give my background and introduction on myself, and we'll get started. So my name is Joseph Jacks. I'm a senior director here at Apprenda, and I've been involved pretty heavily with the Kubernetes project since it was created in July of 2014, so a little over a couple of years ago. I also co-founded a company called Kismatic, which was acquired by Apprenda a few months back, and founded the Kubernetes Community Conference, which is KubeCon, and just really excited to be here with everyone today on this webinar, kind of communicating the best practices around getting started with Kubernetes. So really exciting open source project, and we'll be digging in. Actually announcing this webinar series, we wanted to cover a few items that would be helpful to everyone. So we're actually planning on having this webinar every month over the coming months. And the goal is really to educate the community, educate everyone interested in Kubernetes from a developer operations perspective, or just generally around Kubernetes. Obviously, some pretty experienced folks are presenting this information, so you can expect it to be very informative and educational. And we're actually going to be going through a series of concepts that are really tailored to drive the learning in a sort of an iterative way over the course of the coming months. So some of the prerequisites are listed here. You know, nothing really intense needed. If you have a basic understanding of Docker, that's a good place to start in joining these webinars and learning about Kubernetes and learning about some of the basics. And as we get to some of the more advanced webinars, we might change some of those prerequisites. All of the attendees actually joining these webinars will get $100 of Google Cloud Platform credits, which is really great. So Google Cloud Platform, if you're not aware, is one of the major public infrastructure as a service and cloud platform offerings out there, and with a wide array of services that you can use that $100 credit for. So that's something that's a really nice giveaway that's included for anyone joining these webinars. We're actually also including an annual monthly subscription that you can win for mapped ebook libraries, and we'll talk about that a little bit more as well. All of these webinars are going to be recorded, so you can expect that if you missed some of these sessions, or if you're not able to join the full webinar, you can actually go back online and review all of the content in its entirety online. So we're actually hosting all these at kubernetes.live, so you can mark that and bookmark that link in the future. So what we'll be going over today and some of the objectives in this webinar are a few things, and I'm really excited to be covering a few of these items, and Johnny Karam will be covering some of the other ones. But I guess before we get into this, Johnny, maybe you can provide an introduction for yourself, and then I can just cover a few of these items and then pass it over to you.
Sure. Thanks, JJ. Hello, everyone. Good morning, good afternoon, good evening, depending on where you're joining us from. I'm currently in Singapore while JJ is in New York, and we are
Yep.
very excited to bring you this series of webinars on Kubernetes. So, as JJ mentioned, the objective is pretty straightforward. We want to let every Docker developer experiment with Kubernetes and learn more about it. So, my name is Janaki Ram. I'm one of the Google developer experts and passionate about containers, microservices, and how they enable developers to develop and deploy web scale applications. I have been dabbling with container technologies since 2013. That's when Docker became available, and I've been playing with Kubernetes for the last 1 year, helping customers architect, deploy, and scale microservices. So we are pretty excited to bring you a series of webinars. Even if you miss one, you can catch up with the other concepts. So going forward, we are lining up a variety of topics for you to get started with Kubernetes and learn more about it. So I'll be back again to show you a demo on how to configure your environment and how to deploy your first application. So JJ, over to you.
Sure. Awesome. Thanks, Johnny. So as we covered here, we'll just be going over in this webinar the need for container orchestration. So if as a developer, if you've been playing with Docker and you've gotten familiar with some of the concepts, building images, pushing those images, and creating your containers on your local machine or on a collection of hosts, you really have experienced the power of Linux containers, which is it gives you a very, very flexible and portable deployment environment for your application. You can move that around. We'll really be looking at Kubernetes, which is a way to actually take those Docker containers and make them into distributed systems. And so you're actually able to, with Kubernetes, run large-scale production. Kubernetes has lots of primitives for running production-based applications in containers, and you can run them on any cloud provider on a large number of machines, or even a small number of machines, and take advantage of some really powerful features. So we'll be covering that as well. And then Johnny is actually going to be going over a demonstration of a few really powerful patterns and going over sort of getting started with your. And then we'll actually wrap up the webinar with summarizing everything that we covered and going over some Q&A at the end. So with that, we can just jump right into it. So the need for container orchestration, we're really trying to convey here is, containers through Docker have become extremely popular over the last few years. So since, as Johnny mentioned, since Docker was created in early 2013, we started to see a huge rise and appreciation of Linux containers as a packaging mechanism. So through this, we've seen people use containers to deploy microservices, to do CI/CD much more efficiently, to run distributed applications in these microservice-style patterns, and it's a very developer-centric technology. So Docker has become extremely popular to be able to create this immutable artifact for your application that can easily be recreated in many different environments that have a Linux host OS, as well as being able to share your application itself across many machines in different development environments. So each container image, as is listed here, actually has a few things. So it has your application code, your dependencies, the binaries, configurations, and frameworks there, and also the runtime. And this container image is able to have complete portability across different operating environments that contain the Docker engine. So developers really love Docker for the speed and simplicity and repeatability of container use, and operators also love containers for ease of management and debugging, and really quickly remediating issues that might come up as compared to previous methods, which were obviously much slower and had had a lot of overhead and complexity in terms of actually deploying and rolling out the application. So Docker, as we covered, has certainly solved this problem of packaging, getting your application deployed, and running these containerized applications. And there's really three core components to Docker. There's the container engine itself, which is where you'd actually run your containers. There's the registry where you would store those container images, and there's tools like the Docker CLI and the Docker image format and the different Docker toolkit systems like Compose and Machine and others that allow you to actually manage these containers. And so Docker is actually a really great system as has been popularized for running a few containers or a collection of containers on a single machine, and it was really built around this abstraction of a single machine. So in terms of using the containers and running them and mutating them, the abstraction has really been built for a single developer laptop. But as you start to move from this single developer laptop all the way through to production environments and larger scale distributed services running perhaps across Amazon and bare metal and even your local environment, you need to start dealing with a lot more complex challenges that actually come into play. And these challenges are really distributed systems problems that require much more comprehensive tooling and much more sophisticated tooling to really solve these problems. And so with that, you obviously have your container, your container application, container-based application running from one machine to the next, or getting scheduled from one machine to the next. And the deployment mechanisms obviously change from one machine to the next as well. So, there's obviously qualities of the infrastructure that need to be in place to allow your application to run reliably, and the infrastructure itself has to actually be immutable as well. So where we're going with a lot of this thinking is, instead of thinking of your application as a set of containers running on your local laptop, we can actually take the same abstraction and try and apply that to a much larger scale, and a larger scale as big as a data center. So this is where this idea of taking a data center as a computer, or as a data center as the abstraction, is really coming from. And this is really from Google. So Google has lots of experience in this area. They've been building and deploying and managing distributed systems for a very long time, since the very early 2000s, 2001, 2002, 2003, and they've actually built really the largest scale and most robust infrastructure for running distributed systems in containers than really compared to anyone. So they've actually taken this idea of treating their large-scale data centers as a single machine, as a single computer. And if you begin to think that way of your large-scale services, you can manage them a lot more efficiently, and you can take advantage of much greater utilization, because you're actually enabling your applications to run against a set of shared resources in terms of CPU and memory and disk and networking. And so that's very powerful. So over the last few years, as these ideas have become more transparent to the community and to the public, there's a number of systems that have been built to sort of take this idea of treating a data center as a computer and putting that type of technology in the hands of developers. And so obviously we've seen Kubernetes, but we've also seen Mesos from Mesosphere and from Twitter. And obviously we've seen Docker build Docker Swarm. So the idea of actually taking those containers and those low-level units of deployment of your application and running them in a distributed way in a set of applications that make up, that are made up of those containers, you really need a different set of tooling and a much more advanced set of systems to solve those problems. So what we're actually trying to do is basically fully automate the life cycle and the distribution of these applications to drive up utilization and make things much more efficient. So in order to actually make better use of our data center resources, so that we're not wasting resources and we're not only using maybe 5 or 10% of our compute, we can also increase the utilization dramatically and also release our applications much more quickly because the deployment units are smaller and they're lighter weight and they're much easier to create and tear down and so on. So that's pretty exciting. And with this, I'll actually pass it over to Johnny to cover some deeper information on Kubernetes and talk a little bit more about this idea of the data center as a computer.
Excellent. Thanks, JJ. All right.
Sure.
So JJ alluded on the concept of running one container in one machine, and Docker being the phenomenal tool for managing the life cycle of one container running within one host. But there is a sudden shift in the deployment model and even the thinking around treating your server infrastructure or your data center infrastructure. And that fundamental shift is happening at a level where multiple servers, multiple physical units of computing are getting pooled into one large server or one large computer. So the future of the data center is all about treating that as one massive, large mammoth computer. And this large computer or powerful computer, which is spanning the entire data center, is responsible for running the new breed of applications, which are the cloud native web scale applications that can pretty much handle any level of scale. So the data center is not a collection of computers anymore. The data center is the computer. It is one massively powerful computer capable of running any number of workloads, and the tools are also evolving to treat the data center like one massive computer. So let's take a look at this architecture. So I'm hoping you are able to see my screen. JJ, can you confirm? Is my screen visible?
You know what? Actually, I'll make you presenter, Johnny, so you can actually share your screen directly there.
I'm already the presenter.
Let's see. Actually, yes, I can see your screen, the changing face of the data center.
Awesome. Yep. Okay. So let me walk you through this architecture. So at the bottom of the stack, we have physical infrastructure, and on top of that, we have virtual machines. The physical infrastructure might as well span the bare metal servers. It need not be VMs, but the physical infrastructure could translate into either physical or logical units of compute, storage, and networking. For simplicity, I have taken VM as the unit of infrastructure. Now, on top of the VMs, we are going to create multiple pools, and each pool is going to be called as a cluster. So the fundamental shift is happening in the way the applications are packaged and deployed. Currently, when you're dealing with virtualization and VMs, one application is typically dedicated to one VM. And when you have to scale, you will spin up more VMs and more instances of the applications would run. But that will not drive the utilization of the infrastructure. For example, the application that is mapped to a VM might only utilize 10% or 20%, but extracting more juice out of a VM is not easy because applications are mapped to one VM and VM is becoming the unit of scale. And that's the reason why we are not able to get better efficiencies out of data center infrastructure. The moment we logically start pooling resources from these physical or virtual machines, you can now create multiple isolated partitions, and each partition can be treated as a cluster. And these clusters are capable of running a variety of applications, and these applications are assembled from a set of containers. And if you have heard the term microservices, it's essentially a group of homogeneous containers working together to deliver a meaningful application. That is basically a microservice. Now, within these clusters, which are acting as the logical boundaries of resources, we go ahead and deploy these applications. So these new breed of applications are the microservices running on top of the pooled resources. And now we have multiple levels of layers to manage. We cannot really move away from managing the physical infrastructure. We still need provisioning, configuration management, monitoring, and patching the operating systems. All of that needs to happen. We also need to take care of the clusters because they are the namespaces, they are the boundaries within which the applications are running. So the clusters need to be managed as unified pools, and then the applications also need to be managed, including logging, monitoring, and so on. So we need an Uber layer that is handling the entire stack, primarily the infrastructure, compute, storage, and network, and then the logical pool of resources, which we are calling as clusters, and then the applications. So the new management layer that is evolving pretty fast is called the cluster manager or orchestration engine. And the responsibility of this layer is to manage the entire stack. Whether you are running it in bare metal environment or in a private cloud or the public cloud, you essentially need this tool to manage the entire stack. And if you recall, when Joseph mentioned that there are new breed of tools that are evolving in the form of Docker Swarm, Mesosphere DCOS, and Kubernetes, essentially they fall in the category of the cluster manager and orchestration engine. So they become the face of the infrastructure. Developers will submit their application specs or application definitions to the cluster manager, and it will figure out where these applications will be scheduled, provisioned, whether the resources are sufficiently available. If not, do we need to spin up more VMs and add them to a logical pool, expand the cluster, and then deploy the apps? So all those decisions are going to be made by the cluster manager. And orchestration engine capability will ensure that a set of containers that are logically grouped together to act as one meaningful application are able to discover each other and deliver a unified service to the end user. So that's where we have the microservices pattern, which is evolving. So this is the changing phase of data center. You are not going to deal with individual boxes or individual machines anymore. It is basically treating the entire data center as one unit of compute, storage, and network. So what is Kubernetes? So Kubernetes is highly inspired from an internal Google project called BOT. So Google, for a long time, has been effectively managing the data center infrastructure by creating this pool of resources and running web scale applications like Gmail, YouTube, and Google Search, and so on. So they have been using this concept for almost a decade. And that tool, which is called BOT, is extremely complex, and it can't be just given to normal customers who are running tens or hundreds of machines, because Google scale is very unique and very different. So Google has created a subset of BOT, which is Kubernetes, which is designed around containers and designed around moderate scale that can effectively grow to Google scale at some point by removing the complexity and reducing the complexity of managing really massive infrastructure. So Kubernetes is a subset and a minimal version of BOT that Google has been using for almost a decade. That project, which Google has incubated, has been handed over to Linux Foundation as an open source project. And now there are multiple members. It's one of the fastest growing open source project, where we have CoreOS and Red Hat, Cisco, IBM, many of the mainstream vendors contributing to it. Essentially, Kubernetes is a unified API. It is, end of the day, a set of APIs, REST APIs that you would call to deploy a variety of applications, including traditional web apps, batch jobs that you can schedule, and even stateful applications like databases. The best thing about Kubernetes is it gracefully decouples applications from the underlying infrastructure. So you are never bound to an operating system or a specific architecture or a specific infrastructure. You would only deal with this abstraction, a logical pool, and that's where you will start deploying and running your applications. And it brings a declarative approach to applications where you will basically define the spec saying, here is a stateful application. It requires an SSD backend because I need better IOPS. I need state. And here is a stateless application that can pretty much scale, and I need 20 instances of that to run anywhere in my cluster. And I want to expose a set of these containers which are falling under this group to be exposed on this port. So you will declare your entire application in a language like JSON or YAML, and when you submit that to Kubernetes, it goes ahead, parses your definition, and then gracefully schedules provisions and starts orchestrating your workload. It automates application configuration through service discovery. As I mentioned, service discovery is a very, very critical aspect of running microservices and massively distributed applications, and Kubernetes does that pretty well. It also manages the global state of the cluster. At any given point of time, you can ask Kubernetes what is the utilization, what are the resources available, and what else can be done with the available infrastructure, and Kubernetes will be able to precisely tell you that. It has APIs for doing blue-green deployments, rolling updates, canary deploys. If you have been using PaaS, you're already familiar with some of these terminologies, whether you have been using App Engine or Heroku or EngineYard, they do most of this. So Kubernetes lets you build your own PaaS in a lot of ways. So more on that later. So let's take a closer look at the architecture. What is fascinating about Kubernetes is it's a distributed architecture. So like any other distributed implementation, distributed computing project, it has a master. And this master is responsible for making the decisions and maintaining the global view of the entire cluster. And the master has access to a set of nodes where the real work happens. And these nodes are responsible for running your workloads. So using the API, you would submit a specific workload definition to Kubernetes master. You can also use the UI, which comes with a beautiful dashboard, and JJ and his team has contributed to that, which is now baked into the actual product. So there is a very cool UI. And then there is, of course, the CLI called kubectl or kube control. So you would use any of those tools to talk to the master, and you would submit your workload definition in a YAML or a JSON file. And the responsibility of the master is to understand the definition, figure out your constraints, your policies, your requirements, how many cores does the container need, how many, what is the memory that's required, do you have any specific affinity to a specific node because of the SSD backend or a specific persistence requirement. It will parse all of that, and then it throws the container for scheduling in one. And the job of the nodes is to pull appropriate container images from the registry, whether it is Docker Hub, which is a public registry, or a private registry, and then translates your entire spec to a deployment. So in a nutshell, and in an oversimplified form, this is essentially Kubernetes. It's like any other distributed computing project. You have a master, you have multiple nodes, you submit the job definition to the master, and the job definition contains which container images do you need to stitch together to expose as one unified application, as simple as that. So how do you configure the Kubernetes environment? For a long time, I hesitated getting started with Kubernetes because I thought it is overwhelming, it's intimidating to spin up a cluster, and I need massive infrastructure to even write hello world. That is addressed with the latest version of Kubernetes, which is 1.3, and thanks to a project called Minikube, which will enable you to run a tiny but a complete, fully functional Kubernetes single node cluster on your Windows machine or macOS machine. This is the simplest way for you to get started with Kubernetes, and I'm going to walk you through on the process of setting up and configuring and deploying your first application on Minikube. Once you get started with Minikube, and if you have access to powerful hardware and infrastructure, you can also go ahead and set up a multi-node cluster. And I would strongly recommend you to clone the GitHub repo exposed by CoreOS. They did a phenomenal job of stitching it together, and with just one vagrant up command, you will have a multi-node Kubernetes cluster running on your machine. But you need sufficient RAM and processing power. But this is very good for testing some real-world scenarios and emulating the production environment. And if you really want a low-friction, no-touch deployment of Kubernetes, then you can sign up for Google Cloud Platform and spin up a cluster using GKE or Google Container Engine. So it's hosted and managed by Google. It's covered by a very well-defined SLA, and the underlying infrastructure is obviously Google Compute Engine, and this is the easiest way. And to make it further easier and attractive, we are going to send you $100 credit very soon after this webinar. So these are 3 different mechanisms for you to get started with Kubernetes, but I would strongly recommend you to start with Minikube and then move to the other environments, because Minikube is portable, it is 1 VM, extremely easy to get started. So here are the steps. You can download VirtualBox and install it either on Mac or Windows. And for serious Docker developers, you can also install Docker Toolbox, or you can get the native installer for Windows and Mac. And I strongly recommend you to get this version manager, Docker version manager. And if you come from the Ruby world or Node.js world, you're already familiar with Ruby version manager, which is RVM, or NVM, which is the Node version manager. So Docker version manager precisely does that. It lets you easily switch across multiple Docker servers. This is required because of the Docker server, the Docker engine version mismatch between Docker Toolbox and Minikube. So this will ease that that challenge of working with disparate versions of Docker. So I highly recommend you to install DVM. And a shout out to Rackspace for building this nifty tool called DVM. It's a part of Karina, which is their CAS, and they open source it. So go grab it to seamlessly move between environments. And then get Minikube for Windows or Mac. You can download it. I have a tutorial for you to easily get started. I'm going to leave the link towards the end. And then once you download the binary, just move it to user local bin folder. And then all you got to do is fire up this command called minikube start, where the VM driver can be VirtualBox or Xive. So Xive is a very tiny hypervisor that comes native with Mac, or Hyper-V if you're using Windows, and you can pretty much start a very small VM, which is a self-contained Kubernetes installation. And it will take exactly about 1.5 minutes for you to get your Minikube VM up and running. And after that, you can try Minikube status and kube control get component statuses, and that will tell you whether the installation is successful or not. So those are the steps, and it's time for me to switch to my demo and walk you through the environment. So here we are. So let me show you the Minikube that I already downloaded. So to save time, I have already gone ahead, downloaded the Minikube binary, moved it to my user local bin, and I have launched the VM. So when I type Minikube status, it shows running. So if you are curious, let me pull up my VirtualBox, and you notice that I'm running a Minikube VM here. It's currently based on boot to Docker. So if you are still curious to see what's inside Minikube, SSH, and this will show you something very familiar, which is boot to Docker. And the version of Docker here is 1.11.1, which is slightly older than what Docker is shipping as of now. And this will show you a bunch of images that are required, the system container images for Kubernetes. And let's get out of the VM. And now with Minikube in place, I can quickly point my Docker environment to it. So when I actually type Docker version, you notice that I'm using 1.11.1. But if I actually launch a new terminal window and type Docker version, this is pointing to 1.12. So now if I actually want to point my Docker CLI to Minikube, I'm going to run this popular command, which is eval minikube set docker env. So this will basically create the environment variables for us to point to the Minikube instance. So when you look at the Docker host, it is pointing to the Minikube IP. So this is great, but that's not all. When we actually type Docker version, we notice that there is an error because the client is newer than the server. So the client is 1.12, whereas the server is 1.11.1. So This is where DVM becomes pretty useful. So I'm going to use DVM ls command that shows what is installed on my machine, all the client, the CLI versions of Docker. And I can use this to say DVM use 1.11.1. And now it is using the appropriate CLI. And now when I do Docker version, we are using the version that's compatible with Minikube. So this is basically configuring your environment for Minikube, but we haven't really tested Kubernetes yet. This is just configuring the appropriate environment, through Minikube. So let's go back and understand a little bit of the terminology and concepts. So now that we have Minikube in place, let's understand the terminology. So in Kubernetes world, a node is a machine, whether a virtual machine or a bare metal machine, that's hosting the Kubernetes applications. That means it's capable of running your microservices applications, and it reports to the master. It participates in the cluster and can run the so-called pods and services and basically the Kubernetes applications. So those are the nodes. We already discussed this in the previous slides. And containers, the fundamental unit of packaging. This is becoming the lowest common denominator across all container orchestration engines. So we use Docker for the packaging and the image format. Pods are the fundamental unit of deployment. This is very, very interesting. So pods are collection of homogeneous containers. Now, when I say homogeneous, I don't mean there are multiple instances of the same Docker image, but let's say you want to package a Redis container and a Nginx container because you want to check in Redis before you hit a MongoDB endpoint, and you want that to be available together. So you can stitch the Redis container and the Nginx container together and make it a pod. Because Docker is designed to run one process per container, it is hard to bring in multiple dependent processes together. So pods will make up for that limitation. So pod is more like a virtual machine where you can bring in multiple containers and stitch them together as one unit. But it's not a good idea to bring, let's say, MySQL and Nginx, because you don't want to replicate or you don't want to create multiple instances of MySQL when you want to scale. So pods are typically units of deployment where you put containers that need to work together, that need to go together. And pods can be dynamically scheduled and provisioned on any node. So there is no guarantee that you will hit the same node. So it's not a good idea to package a stateless container and a stateful container together as one pod. So we'll go into the details in the upcoming webinars on the best practices of designing your architecture. But for now, pod is the basic unit of deployment, which is a collection of containers. Replication controller will ensure that we always have the desired state, because when I'm running a set of pods, I want to make sure that I have X number of pods always available. So a replication controller will ensure that we have the desired state configuration of the deployment at any given point of time. For example, I might run MySQL in high availability mode. So I want to run a master and slave. So that means I need at least one instance of MySQL master and a couple of instances of MySQL slave. And I define that as my desired state. And similarly, my web front end, at any given point of time, I want to have at least 3 of them. So I can tell that I need 3 replication controllers of my Nginx pod. So it will ensure availability and scalability. And that's how you can scale out and scale in pods at runtime. Labels are the real glue between various objects of Kubernetes. So how will replication controllers identify that it needs to scale out a set of pods? So the labels will connect them. So they are basically tags that you will attach to every object that you create in Kubernetes, and using those tags, you'll be able to filter and you'll be able to mix and match a variety of resources that are running within the context. Services are the way by which you will expose a collection of pods to the outside world. whether it is internal. For example, you never want to expose MySQL pod to the outside world, so you can expose it only within the cluster, whereas a set of Nginx pods running as a replication controller would be exposed to the outside world, so you will expose it at the node port level. Again, more on that in the upcoming webinar where we do Kubernetes 101, but essentially a service is a way for you to expose your pods both internally and externally. So let's go ahead and take a tour of the environment and also deploy our very first application. So I will come back to the command prompt again. And what I want to show you here is 3 different environments. So we have already seen Minikube. And how do I know if my Minikube is working well? So I will fire up a set of commands. For example, kube control is the CLI that is consuming Kubernetes API. So I can actually type kube control get nodes, and this is going to show me the available nodes. Okay, I'm using a different environment. Let me set the context to Minikube, and we'll come back to the other ones in a second. So when I type kubectl get nodes, so this is going to show me how many nodes are currently running. And since we are using Minikube, there's only 1 node. I can also check the component status. So getCS is a shortcut to check the status of our cluster, and everything seems to be fine. The scheduler is healthy, the controller manager is healthy, and the HD, which is the distributed key value pair database, that's also healthy. And the next one is basically checking if you have any pods. Obviously, there are no pods. But this is Minikube. If you notice, let me pull up my virtual box. You will notice that I'm running a set of VMs within Vagrant, and this is actually the CoreOS Tectonic cluster that I set up on my machine. So from Minikube, which is a dev environment, how do I switch to slightly more production-ready environment, which is Tectonic? So it's pretty simple. I can use kubectl again to say config use context, and I have a predefined environment called Vagrant Multi. So this is going to now switch to the CoreOS Tectonic setup, and now let's repeat the same command. So get nodes will show me a different set of nodes, and the kube control CLI is now pointing to a CoreOS Tectonic cluster, and this is my current setup. We can also repeat the commands that we have tried earlier. Again, the component status shows healthy and everything is fine. When you really want to do at something at the production level, you can always switch to GKE. So if you are still seeing my screen, you will notice that I'm running a cluster in Google Container Engine called Johnny Kubernetes, and there are 5 nodes within this cluster. So it just takes a few minutes for you to go ahead and spin up a cluster in GKE without ever creating a VM. So I can also switch my environment pretty quickly to the production cluster. So gcloud container clusters list. This command will show me the available clusters in GKE. And there we go. So Johnny K8s, which is a shortcut for Kubernetes, is up and running. Once I have that ready, I can also execute this command, gcloud container clusters get credentials followed by the cluster name. So this is going to grab the certificate and the credentials required to talk to the endpoint. And now, guess what? We switched kube control from the Tectonic cluster, which is running locally, to GKE, which is Google Container Engine. So kube control get nodes. So this is going to show us 5 nodes running in Asia Central. So 5 nodes there, and let's also check the health. So this is perfect. It's actually running 2 different instances of XD. I can also check if I have any pods deployed by typing kube control get pods. Obviously there is nothing. So it's pretty simple. You can start with Minikube and you can keep switching your environments using the kube control command. So that is the CLI, which is able to talk to multiple endpoints, whether it is Minikube or a Vagrant setup or even a bare metal, or something like Google Container Engine running in the public cloud. So that is how you will get started. But let me walk you through a set of commands where we will actually deploy an application. So before that, let me switch back to Minikube. So it's pretty simple: kubectl config use context Minikube. So this is going to switch to Minikube, and now I'm going to walk you through a set of commands. So this is my first command where I'm going to create a deployment. Again, this is not to overwhelm you, but to show you what I'm actually trying to do. This is creating a very simple deployment. We are not even creating pods. We are not even creating replication controllers, anything of that kind. This is called a Kubernetes deployment, and this is very, very simple to running a Docker container on your local machine. And the command is very similar to docker run -p followed by port and the image name and the container name. Very similar syntax and semantics, but instead of creating just one container, this can basically create multiple containers grouped together as pods. So let me go ahead and run this. So it has created a deployment called my-web. So I can now get deployments, and this shows that the desired count is 1, current is 1, up to date is 1, and it's created 7 seconds ago. So pretty new. So now I can go ahead and get the pods. So this has created a pod with a ad hoc name, with a random name, because I didn't mention the pod name. I just asked it to create just a deployment with one pod of Nginx, and that's exactly what it has done. I can even go ahead and create multiple pods and I can scale, but that's not the objective of this demo. I want to show you how you can create a very simple Nginx deployment, right? So if you are really curious to know how to package this as a pod and scale it out as a replication controller, stay tuned and do sign up for our next webinar, and that's where we're going to walk you through it. And once we have that, which is the Nginx pod up and running, it's time for me to create what is called as a service. So a service is a mechanism for us to expose the running Nginx deployment to the outside world. So when I say expose deployment my-web, which is what we created here, target port is 80. So that means the outside world will be able to access the Nginx deployment through port 80 of the VM or the bare metal or your cluster. And we are using type node port, which means basically we have to grab one of the IP addresses of the node and hit port 80 on that. So when I actually run this one-line command, it creates what is called as a service. So now you'll actually see that I've been running other services as well, but my-web is what is interesting. So it is currently created within the cluster with this specific IP address. And if I really want to access that, because we are exposing port 80 on the node, it's pretty simple. I'm going to grab this to the environment variable, which is port. Okay, and you will notice that it's actually showing a random port that's assigned to our service. That's because we really want to make sure that the node port is falling within a range, and that's how Kubernetes exposes the services to the outside world. So when we hit this port, it basically translates to the target port, which is port 80 of the Nginx. So now we'll also grab the Minikube IP. So when I type Minikube IP, it actually shows me the IP. Now what I'm going to do is get that into an environment variable, and then we'll do a curl to the port and the IP, and there we see the Nginx welcome page. So if I want, I can also access this from the browser. Now let's check one final thing, which is the dashboard. So when I type Minikube dashboard, oops, there is a typo there. Give me a second while I fix it. So Minikube dashboard will open up the dashboard in the default browser, and you will see that there is a deployment called my-web, and there is a replica set with exactly one pod and which is this, and then there is this is a replica set, and this is the pod. So this is how you visualize the services. So if you actually click on this, you will notice the IP address of this pod and all the events that it has generated and so on. So this UI is pretty cool, and you can launch that by typing minikube dashboard. Now the best thing is I can pretty much repeat this process by just shifting kube control to talk to one of my other clusters, but the process and the workflow remains exactly the same. So that is the power of Kubernetes. Whether you're targeting your local environment with Minikube, or your staging environment with a Vagrant setup, or production running in GKE, the set of commands remain the same. And this is what makes Kubernetes very, very accessible and very powerful. So that brings us to the end of this demo and also the session. Let me take you back to my slides and summarize what we have articulated so far. So Kubernetes manages containerized workloads running in production. Docker is phenomenal when it comes to one machine, one container, and managing the lifecycle. But Kubernetes does that at a massive scale. Hundreds and thousands of containers running on tens of hundreds of physical machines or virtual machines, and Kubernetes can handle the orchestration pretty well. It's an open source community-driven project initiated by Google, but now it's managed by Linux Foundation. Anyone can contribute, and you can actually go ahead, explore, and even you can contribute to the Kubernetes project. Like most of the distributed computing environments, Kubernetes has a master and it has multiple worker nodes. Clients interact with the master through the REST API. Kube control is just CLI written in Go to talk to the master API endpoint, but there are language bindings available for almost every language. You can actually go ahead and try that. Kubernetes deals with APIs, which will translate to object operations. So pod, replication controller, services are all objects, and they have APIs that you can consume. Minikube is the simplest way for you to get started. And if you are looking for a detailed walkthrough, a couple of days ago, I published a tutorial on the new stack. The link is here, and you'll also get that when we upload this to the slide share. I also put the scripts and the source code for the demo shown today on GitHub. You can actually clone the repo and go through all the steps that I have shown you to replicate this on your local machines. So that brings us to the end of the webinar, the very first webinar in the series of Kubernetes community webinars. And if you are interested in learning more, particularly digging deep into the details of how to create your first pod, how to create a replication controller, how to create a service, what are the best practices, stay tuned. The next webinar is all about that. We'll actually open Sublime Text and create a pod end-to-end, deploy it and scale it out, and then expose it to the outside world. So if that excites you, come back on 29 September. We are going to send you an update very soon. In next couple of days, we'll also send you the credits for you to sign up with Google Cloud Platform and spin up your GKE cluster to try out in a live environment. And you'll also, if you're the lucky winner, you'll also get a subscription to Pack Publishers annual subscription of an ebook library. And a couple of you will also get access to it for 1 month. So stay tuned, and thanks again for joining. We are now open to Q&A. So let me switch to the questions tab.
So we've seen quite a few questions come in here, Johnny. I think the most recent ones are near the bottom. I've answered a few just one-on-one to folks as the webinar has kind of been progressing. Looks like we've got a few here around Minikube, around if the slides and the videos will be recorded. So yeah, I guess I'll just go for that one. So everything will be recorded and available online at kubernetes.live. So you're all encouraged to go there, and we'll be publishing that in the near future.
Cool.
There's actually another question here on how to volunteer, Johnny. So maybe you can take that one. Some Prasad Gadaraju was interested in wondering how he could volunteer.
Volunteered for the Kubernetes webinars. So for the first few webinars, we're actually looking at getting people with hands-on experience. But if you want to help us with driving the awareness and helping us get word of mouth, you're most welcome. Spread that in your local communities. Tell your friends, your family about what is Kubernetes and start getting us more audience, because it's all about getting developers involved and getting them excited about Kubernetes. And once you gain more confidence, we'll be happy to have you as a speaker, as a guest speaker, because
Yeah.
this is a community initiative, and we are going to have multiple speakers from the ecosystem, and we look forward to having some of you co-host and join us in this effort.
Yeah, and if you're interested in contributing anything specific, I'm pretty sure you can email us at info@kubernetes.live. Correct me if I'm wrong there, Johnny, but that email will get to us, and we'll be able to incorporate any feedback and any help that you might be able to provide. So just looking at some of these other questions here, it looks like someone was asking, what are the RAM requirements for running Minikube?
Interesting. So I actually ran it on a machine that only has 4 GB RAM. So technically, if you have a decent processor with at least 4 GB RAM that's capable of running VirtualBox, you can pretty much get started and have Minikube up and running.
Awesome. Thanks, Johnny. Another question from Jagadesha was, can you show which command you typed after get pods in the CLI?
I don't remember, to be honest, but guess what? The entire workflow is available as a detailed walkthrough on the new stack. You can go check it out. So you can pretty much replicate all the steps on your local machine.
Awesome. Yeah, I think another question here, one more question that I saw that would maybe interest folks, Johnny, was how do replication controllers compare to deployments?
Yeah, so deployment is like the Uber definition will comprise of pods and replication controllers. So replication controller is a subset of a deployment. In fact, right when I'm creating the deployment, I can mention how many replication controllers I need for that specific pod. So think of deployment as an Uber definition of my entire deployment, if I can call it, and replication controller is just a subset.
Awesome. Thanks, Johnny. I think maybe one more question, and then we can wrap up on the Q&A, is from Gajanan on how can I set up a multi-node Kubernetes cluster?
The easiest for you is to search for CoreOS Kubernetes Vagrant, and you will hit a GitHub repo. Just clone that, go to that directory and type Vagrant up. And in about 10 minutes, depending on your machine's power, you'll have at least a 2-node cluster with 1 master up and running in your environment.
Awesome. Cool. Well, thanks again for having me, Johnny. And I think this was really useful and valuable for a lot of people. I think we got most of the interesting questions answered here. And I guess for now, I'll say thanks again to everyone, and looking forward to seeing you all at the next webinar.
Thanks, JJ. It was great having you. And do sign up for the next webinar, folks. And we have very interesting sessions lined up. Thanks again for joining, and we'll see you in the next webinar.